Hi, my name is Anthony Carlleston de Lima. I am a junior data scientist at Smart Brazil, and today I will show you my presentation about IBM course, where I create two models, a regression model and a recurrent neural network classifier that will try to predict the closing price of the Itaú Brazilian Bank using the InfoMoney news. So all the project was deployed on the using the IBM services. So I hope you enjoyed.
Predicting the exact price of a share is a task considered impossible for many experts. However, with the know-how and years of experiences, it's possible to predict some fluctuations generated by notions and market experiences, even as some jokingly say, good feeling. The project has there to predict stock market prices, with a focus in the closing price, using exogenous variables such as Ibovespa, where it's similar to Dow Jones, and dollar price in reais. It's very important to know what's happening with the company that we want to predict the price shares, and there is nothing better than classifying the scenarios that is. So it was added the Itaú News in three scenarios: positive, negative, and neutral, represent the optimist, pessimist, and neutral feelings respectively. The solution to use the case is a regression model deployed on IBM Analytics Engine and some ETL job schedules, running every 10 a.m. from Mondays to Fridays. Using IBM Watson Studio that will extract, transform, and load, so it is where the recurrent neural network will take actions. After running the regression model, the predicted values that will be available for stakeholders, where it's possible call the output using REST API and connect with the preferred BI tool. The initial time series dataset has the information such as date, open, close, high, low, price of the three time series. The close variable in I2B4 dataset is the target variable, so the features will be used are Ibovespa and dollar price in reais. For the classifier dataset, I had to create it, so I selected the 54 Itaú News and classify it manually in three scenarios, as mentioned previously. Although I am not a financial expert, I had to do this to feed my model. After creating the scenarios, it was added as a dummies variable. So now I will show you how the backend will need to do to running the processing and get the predictions. After the ETL processing and storage the both of datasets in the Hadoop file system, we can run the script on IBM Analytics Engine using Spark Submit. Using the SS8 connection, we can execute command lines on the cluster. Executing a ls command, we can notice that the PI script is ready to be used. So it's here. I paste the Spark Submit command. It's available in my GitHub to use as an example. So I will explain what which parameters means. The master specifies the master's address using our node. The executor's memory will specify the amount of memory to use per executor's process. The deploy mode is represent the driver locally as an external client. This is the application name. The config specifies the Spark configuration property, file path to the Python code. It is the first input used as sys.arg1, and this is the second input used as sys.arg2. And now I will execute the code. I will skip the process to don't spend your time. So we can notice that there is a pretty.parquet folder, so it is where the output. Success is the status to the restoration in the Hadoop file system, and the part 0000 is the output in .parquet. And now I will use a notebook to represent a BI tool to visualize the result. Starting and execute the cells and load the packed file, we have a pandas data frame. We can notice that the closing price today is around 26.73. And the root mean square error is high. It's about 60 cents. And the correlation in R squared is close to 1. All the project is using IBM services to avoid cloud migration, so that wastes the costs. The project will have two external data sources. For the news used in the project, it is used the economic website called InfoMoney, and the data source for the time series Itaú stock price will be B3. The web API is a simple and fast way to get information from an external dataset. There is a high power integration, optimization of the internal management, feasibility of the partnership, and customization of services. The IBM Analytics Engine allows us to storage the data in the Hadoop file system and processing with Apache Spark. The Spark is a cluster computing system that is faster analytics than Apache Hadoop, easy to use and multilingual, where I needed to rewrite the regression model using PySpark language to run on this cluster. The extract the news is used the web crawlers, but the first step is the Google Search API, where it will get the news links using the scrap for extracting the data from the website. The Google Search API was chosen due to the facility and stable these APIs allow us to get 8 links with the free tier, but there isn't more than 8 news of data per day, so it is fitable in the project. The Scrap is an open source and collaborative framework for extracting the data from the websites in a fast, simple to use way as long as you know which elements in the CSS you want to extract. Using the Scrap text response, we can select the CSS party what we want. To get the continuous variables of the time series, the project is using Yahoo Finance API. It is free and stable too, and has all the necessary time series that we want, where the free tier gives 500 calls per month, so it's not worry about that. The Hadoop file system is faster than MongoDB using Apache Spark, so the purpose of the technology is high performance due to parallel processing. The IBM Cloud Object Storage is used only to storage the ETL data, so there are 3 small datasets that will gather and storage on the Hadoop file system. Fortunately, I have a good data source. The time series using Yahoo Finance API, there isn't noise and is completely reliable. The missing values are found only on weekends, so for the stock market analytics it's considerable that the day of weekends is removed. The news there aren't typos, having only special characters, very simple to clear. And having completely different from what I'm used to work, where the user is misspelling all the time. Resampling by month, we can see in the half of the year 2019 until February 2020, the stock price were stable. So in March, it was the longest interquartile distance, where we can conclude that something's happened there. It was where the COVID-19 pandemic hit the Brazil and unsettled the stock market. Applying a decomposition in the time series, we can estimate the trend, seasonality, and residual, so we can try to use the seasonality at Remax. The ACF suggests there is a long memory present in the dataset, so that long-range dependence. It's a characteristic of the no stationary time series. I check it using the defuller in the notebook, and there is a strong indication to use lags as a feature. Correlation is an important step to identify the features that has a great impact in the target variable, eliminating the variables with a low correlation. In the deep learning, it's similar to L1 regularization that avoids the features with a low impact in our model. The features that have a significant impact in our model is open Itaú price, open dollar, open Bovespa, and positive and negative news with a weak correlation. All the continuous variables have a correlation greater than 0.77, and the news is a weak correlation with a positive and negative 0.33. The unique preprocessing that was applied to the time series features was scaling. It was necessary to avoid the larger scale feature impact more than the others with a small range. It will center into the mean and component-wise scale to unity variances, turning the range of the features less sparse. However, the preprocessing of texts is a little more complicated. I created this pipeline to turn more easily to explain. This process is divided in two parts: the data cleansing, that are to clear the text, remove the numbers, stop words, accents, and punctuations, and transform the whole text to lowercase. All these steps will ensure to create a correct word embedding in the next stage. So, in the features engineering, I will start with tokenizer, that is splitting the words and apply the patch sequences. Where the text is listed with words tokenized and transforming into a 2D NumPy array. So with this 2D array of words, algorithms will exchange the words for a vector with 50 dimensions. Gather all new words embedding. It's going to generate the embedding matrix. I know it's a little confusing, but it's very important and consider it state of the art. Understanding it, you will understand almost everything of the neural networks very clearly. I left some links in the notebook if you are interested to know more. Comparing these four regression models, the model that had the lowest root mean square error and the highest R squared was the linear regression model. As the goal is to predict the exactly closing price and added in the financial analysis, it was the model that came closest. The coefficient of determination, or R squared, measures the proportion of the variation in the dependent variable that can be attributed to the independent variable, where all the trained model was acceptable. I split the dataset in train, test, and validation set. So in the test set, the F1 score was 0.6 and the validation test was 0.71. So it is a high bias case and need to increase the size of networks or train longer. But if we analyze the F1 score of the validation test, we can notice that the class N had the F1 score of 0.25. So we need to insert more data with this class because it is not clear to our model. Adding more data in general is not a bad idea, as long as the classes are not unbalanced.
And here we finish my presentation. Wholly the project is on my GitHub in the link below. There are a lot of references there, so I recommend to spy it. That's all, folks.